Well, look what we have here. We have an unalive DX1. This is housed at the University of West London, and it belongs to Pete Townshend. And I've got a particular interest because I have a couple of cartridges with my own sounds which I'm so eager to try and play through this DX1. There's two screws on each side which, when you remove, you can just take this lid up like a bonnet of a car. Now this is the power supply we're going to have to take out. Unfortunately, this is a 110 volt version of the DX1, but I think someone plugged 240 volts into it by accident. So everything's looking quite clean and tidy. That's the power supply that we're going to remove today. And here's some of the fantastic digital goodness. Which is very different to the DX7s I'm used to. I'm just hoping that there's no damage done to the DX1 itself. Some custom ICs there. And I have to say, this battery, I'm not sure if that's glue. I don't think it's leaking. I'll have to check that out later. And the keyboard, let me just see if I can focus. It's a beautiful wooden keyboard. Very nice. Unfortunately, it's enclosed, so we're not going to get to see its action today. So the power supply connects to this distribution board here, which might be useful. You can see there's some marks, so I think someone's been here before. So we need to unplug these. And to get this out, there's two screws on this bracket here. And there's more screws on the back, which holds the power supply in. And this is also part of the power supply. It's like a filtered input. The fuse is blown at the moment, so obviously some things have gone very short inside. So let's just take these out. And if you're wondering why I'm working on the floor, it's so it doesn't drop on my head. Okay, that's that out. And this matches up with the schematic CN11 and 12, which is the power connectors. Just have a quick poke around for any shorts. I guess this is where they're tying all the grounds back together. I think a much better idea for me is to measure the resistance between all the pins. I'll make a little database sheet. And there we can see I've got this all mapped out, so I can come back to this just so we can check that there's no shorts. The minus 15 digital looked a bit dodgy. Okay, so we have everything we need out to take it back to the bench. We'll just close her up and just make sure nothing's gonna catch. Look at that, beautiful. Okay, excellent. Well, this is exciting. We have the literal heart of a DX1 on the bench. I have to take it all apart and have a look, see what's inside. This is where the mains first comes in, which is just basically the filter section. I don't imagine the short will be in here. And that's that. Okay, so I've taken the lid off the main power supply now. We can have a quick look around. That resistor looks a bit dodgy. Bit gooed up, but no signs of any burning. No signs of any burnt transistors. This green package here is what I'm most worried about. This is the IC that does the switching for these two MOSFETs, and if this IC has been blown, that could cause us a lot of trouble. And this is the secondary side. Lots of filtering, and it has a plus or minus 15 volts for the analog, plus or minus 15 volts for digital, a plus 5 volts, and a 1.2 volts. And luckily, these MOSFETs and power regulators are mounted on this panel here, which means I don't have to unscrew all these ICs to take the unit out. I can just unscrew 2 screws at the back. And the final screw, and it should slide out now. We can get to see at the bottom of it. So a couple of washers left in there. There we go. So having a look, it's pretty gooed up. Not as bad as the Akai that we saw before, but I don't see any burning. I see a lot of old flux. It's a shame they didn't get to clean these, unless there's been some repair job on it before. It's quite possible. I don't know the history of it, but yeah, not looking too shabby. I'm really pleased that there's no, focus the camera, no burn marks at all. So that's a good sign. So I guess the first thing that we should do is check out this bridge rectifier. It's quite easy to measure. There's the 4 connections here. Oh. Oh, everything's short. Okay, that's definitely got to come out. So I'm going to apply some flux. And this should help the solder move a lot easier. I'm going to try my desoldering pump. It's quite difficult. Got a funny feeling the legs are too thick. Just suck off a bit of the side. I can see the leg now. Yeah, it's too big. I have to use some braid. So I've got some braid out. Let's put a bit more flux. And a little tip for you here. Always leave a bit of solder on the end of your braid. This is going to act as a really good conduit for the heat, so you get a good heat transfer, and then you'll see the solder wick up the solder braid, and then you can just slowly work your way up the solder braid, but always start where you left off. and we don't want to get the pads too hot. Okay, so here we have the bridge rectifier, and first of all we're going to measure from this AC input to the positive, and that's acting like a diode, so that's good. Let's just swap them around and we shouldn't get a reading in this direction. Okay, so that diode is okay. Let's try across these two pins. Oh, that diode's gone short. Just double check, reverse the pins. Yeah, so that diode's short as well. Let's try, which one do we need to do next? This diode across here. Well, that measures correctly. We'll just check reverse polarity. Okay, so we have two good diodes, and we also have two shorted diodes. Let's just see if there's any shorts left on the board. Okay, we've cleared the shorts across the AC input, but there's still a short on the DC output. Just double check all around. But yeah, definitely it's just the output now that's shorted out. Have to go dig a bit more. So you can see here I've marked out which diodes have gone short, and I'm interested now in these two resistors. So let's have a closer look at them. So if we look for R2, which is this one I spotted earlier that looked a bit dodgy, seems to be cracked on the top, and it's supposed to be a 10 ohm 7 watt resistor. I think we should just try and measure it in circuit and see what it reads. Should be 10 ohm. 56 kilo ohm. So we're going to have to take this out to measure it properly, but the 10 ohm should have been read.
A billion years of earth, wind and fire around my brain. The current's so strong, so I float along.
Had to pull it out because it has got a bit of glue on the bottom of it, and it's got 3 legs to it, so it should just be one resistor. Let's try and measure it. Okay, so I guess one of the legs is just to help hold it in place, and I can get my probes on. That's measuring in the meg ohms, and 223 kilo ohms, so nothing like the 10 ohms that we're expecting, and it seems really shaky on the probes, so I suspect that this resistor is blown. 7 watts. Woo! So before I check R3, actually I'm just going to quickly measure these bypass caps. There's 3 of them there, one massive one and 2 smaller ones. I'm just going to just make sure there's no shorts across these. They're okay. Ooh, that one is short. Let's take this out. It's quite unlikely that a cap goes short like this, so when I take it out, it might be an indication that there's other shorts on the board. But this is the main cap that goes across the output, positive output. So there's a possibility that some current went through this. Okay, there she is. And let's just check her out of circuit. Yeah, that cap's short. It's not often you see that. Crazy. So I'm just for a sanity check, I'm just going to run it on my Peak Atlas ESR meter, and yeah, in circuit leaky. Yeah, crazy. A shorted cap and a shorted diodes. No wonder the fuse blew. And this is 220 microfarad, 400 volts. Okay, let's just see if we've cleared these shorts. That's the AC input and the DC output. Yeah, look, we're all clear. That's fantastic news. Yeah, can't find the short anywhere. Okay, well, I think I might just take these other two caps out. It's easy to see which way around they are, so.
They're pulling a billion years of earth, wind and fire out my brain. The current's too strong, so I float along. Don't care if I ever see the shore again.
There we go, I can just snap out. And at least this way, this is going to give me a bit more room to measure some of the other components. Things out the way. And we can check them for peace of mind. I don't think that's like leaky capacitors. I think that's just the glue holding them in. So let's just quickly measure them. 40-year-old caps. Let's see how they do. Okay, not bad. Not bad at all. I mean, I would really recommend a real full recap of this if we can get it working again. But even that one's not too shabby at all. Excellent. Well, at least they're not blown up. Yeah, and I'm pretty sure that's just glue. But still, a full recap would do this thing a world of good. Okay, so there's a direct line for the 240 volts to this part of the circuitry here, feeding the analog plus or minus 15. There's Q1 and Q2 and a diode. And if we look on the board, I can see there's a pair of diodes joined together there. But there's Q2 and there's Q1. So I guess we'll try and get them out. So we'll just measure D2 in circuit, and yeah, we get a nice voltage drop there and no resistance that way, so D2's fine. Okay, and there's Q1. Let's take Q1 out. Okay, Q1 was good. So let's try Q2. This is Q2 here. Let's take her out. and I'll test it on this meter. And the survey said NPN. Perfect. So that transistor's good too. Okay, so as that's good, I can solder that back in and I can mark it on my sheet. So R8 seemed interesting. It's down as a 5K7, but here you can see it's an 8K2 and it does measure 8K2. Well, I forgot to measure R5, it should be 22K, so that's good. And R4 here, it should be 1K. I can get a good connection. Now I think I'm going to have to take it out. Wow, 1K exactly. Okay, that's good. Okay, now we didn't check R3 earlier, so let's try and measure that. Should be 470 ohms. Ooh, 5 ohms? No. We're going to have to take this out as well. It definitely looks like 470 ohms. It's not often you see it written like that, 0.47 kiloohms. Okay, I've got the resistor out. And sort of measures out of circuit. Not short. Actually, this is measured 0.47 ohms, so I've had to use a 4-wire measurement here to get that, and that's looking good. So CR1 is this component here, which I think is a triac, so I guess I should have to pull this out as well and check it. So if you measure resistance between T1 and T2, we shouldn't get any reading, and if I switch my meter into diode mode, we should get a voltage drop between the gate and one of the two pins. One should read open circuit. Yeah, that one, and hopefully, yeah, we got voltage drop there, which would normally be about 60 ohms or something like that. Let's just check the resistance. 79 ohms. I think this triac is okay. Great stuff.
So I give up and let destiny rule my fate, riding with the tides of the moon. Not all comes to those who wait.
So they're using two diodes here. There's the first voltage drop, and as you'd expect, almost double. And I just want to check the reverse polarity. Yep. Okay, this diode's great. just found this R20 here, and it's labelled 0.22 ohms on the schematic, and I'm getting 1.4 ohms. So again, this requires a 4-wire measurement to get a good accurate result, and there we can see 0.21 ohms. Very good. Another anomaly on the schematic, R23 here. It says 47k, but it's actually 100k. Okay, so the last things I need to check are the MOSFETs that are going to be driving the transformer. There's a diode on there, which is actually part of the secondary side, and I think it's going to be easier if I just unsolder all these ICs, because they're just mounted on this one panel and I won't have to unscrew them individually. So I think this may be the quickest way to do this.
The pulling a billion years of earth, wind and fire out my brain. The current's too strong, so I float along. I don't care if I ever see the shore again.
Okay, that's really cool. I don't have to remember where everything goes either. And I can easily measure this now with my meter. So let's start with these MOSFETs. And we're going to use my trusty Peak Atlas DCA Pro. And hopefully it should recognise these MOSFETs. And let's hope they're good. Oh, great. That's looking really good. That's a really good sign. Let's measure the other one. We're going to get lucky. And yes. Okay, great. Now that's really good. Because I don't know how easy it would be to replace these particular MOSFETs. Let's just quickly check this dual diode. Now this is on the secondary side, so if this is good, then that would be really good for the secondary side, because hopefully that might not be broken. It's taking its time. But no, it's found 2 diode junctions. Brilliant. So there's high hopes for the secondary side of this switch mode power supply. So after all that work, it's really gunked up with flux and stuff. I'm really going to have to just quickly give it this thing.
The pulling a billion years of earth, wind and fire out my brain. The current's too strong, so I float along. I don't care if I ever see the shore again.
Nice, it's not sticky anymore. We need to check this secondary side. I had a quick look, couldn't find anything. And also I was able to map out the voltages from these pins, so that I can use my little database to figure out if there's any shorts on the DX1 itself. So I'm a bit worried about this -15. Yeah, that ended up to be a really useful endeavour, because now I can see quite clearly on the -15 volt analog to ground there's 7k5 resistance. On the +15 volt to ground there's a 3.3k. The -15 digital to ground is 1.2k. That was one I was worried about, so that's really good. The +15 volt digital to ground is 1k, and then we have the plus 1.2 volt, 2.1k, and the lowest reading is to the 5 volt, which is 272 ohms, to 274 for some reason, even though those are all tied together. There's a little bit of difference there. So yeah, nothing too scary looking like on the DX1 side of things. And now we'll just have a closer look at this filter board, and I can see these reefer caps are cracked. They're ready to blow any time. Let's get them out. Let's hope this shows up on the camera. Look, you can see a crack there. And when these blow, they really do blow up. So it's a good job that we actually caught this. This one is even worse. Yeah. They're not a pretty sight when these go, I tell you. And there's the 4 amp fuse that blew up. Nasty. Let me just quickly do a continuity test with the power switch. And one of these should turn on and off. Cool, so power's getting to there. Not shorting out anywhere else. And we'll just try the other terminal. Excellent. So this is all behaving as you'd expect. Now this wire here I think has something to do with changing it to 200 volt. But as we're 240 volts here, I'm not really sure that's going to work. I was doing some in-circuit measurements of these caps on the secondary side, and these 3 seem to be measuring in-circuit leaky, but they are all high-value caps in parallel, so I'm just going to take them out just to double check they're okay. Okay, let's quickly measure these 40-year-old capacitors. How exciting! Oh, 5.4 is quite high. Not bad value though. Should be 4,700. Let's try this one. .6. It's even higher. Pretty good on the value though. 3.8 is much better. Okay, so there is no faulty capacitors here, but yeah, definitely needs replacing. To recap on what we found, 240 volts came in here. These 2 diodes got wiped out, and also this capacitor. So current can quite easily go back the other way. We found that R8 is labelled 5.6k on the schematic, but it's 8.2k in real life, and similar with R23, this is actually 100k on the board. I see no reason to change these at all because it was working beforehand. So everything else checks out, and considering all the damage seems to be just around this area, even this slot is unscathed. I think there's a high chance that this switching regulator might be okay, because even if it's in the 200 volt setting, it gets its power through this 15k. So if we were putting our 240, it does go through this little inductor network, but that goes through the 15k. I'm going to have to do a little bit of more research to see if there's some way I can measure this switching regulator IC to check it. So I'm going to order some new components of these ones that are blown, and a couple of the reefer caps. put the whole thing back together again. I'm going to have to buy a step down transformer because obviously it's going to be 110 volts. Okay, stay tuned. I'll keep you updated. Catch you next time.